In this video, I will be walking you through the full process of structural analysis and design using the software ProtaStructure. I will show you how to set your project, define your structural element, and most importantly, choose the right materials for your columns, beams, and slab, ensuring strength, stability, and cost effectiveness. I will also highlight key safety measures you need to take to prevent building collapse and how to implement proper quality assurance practice right from the design phase. I'm Miracle Okeke Richard. Welcome to SamGoz Engineering. And in this channel, we help you develop the required skills and enhance your knowledge to elevate your engineering career. And if this is what you want, you can quickly subscribe. This is what we are able to achieve in our last video where we successfully modeled this in this software ProtaStructure 2025. So in this video, it will all be about analysis and design. But first, there's something I forgot to mention in our previous video. That is to include the height of the finished floor level. So I'll come to story operation. I'll go to edit. So this is it. First story bottom level. First story bottom level, what it means is that the difference between your finished ground floor and finished floor level, like that's the difference between your soil and the difference in height between your soil, and that's your ground soil, and your floor and your finished floor, that's where you place your terrazzo and the rest. So that's different, and we're using it as 450. So that's what I forgot to include in our last section. So I click on OK, then it will open. But I'll then go to analysis and design. But before I go to analysis and design, I'll first of all turn on my grid lines and everything. So to turn it on, I'll come to display, I'll come to layer, I'll turn on my axis, I'll turn on my ghost axis, turn on my plane definition, and turn on my text. So after I've done all this, the next thing to do now is to go and carry out the analysis. So I'll come and click on analysis tab. Click on analysis tab, then I'll click on building analysis. I'll click on building analysis. Once I click on building analysis, this dialog box will appear. So first thing to do first is to come and edit my material. So I'll come click on edit material. So for the concrete grade I would like to be using here, I'll just click on it. So I would like to be using 20. Now look at it, compressive strength of 20 Newton per meter. So this is what I like to be using. I'll click on apply to all members. I'll click on OK. Then come over to the steel grade. So this is the steel grade. I'll click on it. The steel grade I would like to be using here is grade 460. I like to be using grade 460. I'll also click on apply to all member. But look at rebar diameter. I'll come here, click on edit to edit my rebar diameter. So for this my column, I like to be using 16. So I like to be using 16. This is it. Then for my shear wall, okay, initially I don't have any shear wall, so I'll just save it. But for my beam, I like to use 16 for my beam. Yes, I like to use 16. For my slab, I like to use 12. Yes, for my slab. Then if there is any checked one, you uncheck it and just only see me. I mean, some people will do, let them choose between 16 and the 20. But me, I normally like choosing only 16, because if I finish choosing 16 and 20 doing interactive design, those ones that software gave me as 20, I'll still convert them to 16. So for me, there's no need of doing 16 and 20, or else I'm doing all this high-rise design that I'll not be doing 16 and 20, because I know that the client will be able to afford 20. So if I'm doing a duplex, if I'm carrying out a duplex design now, I'm having Y20 in my reinforcement. If I submit my structural detailing or my BOQ, you see the client might not even look at my work set, because he's seeing Y20, saying but all the duplexes are Y16. So that's why I don't normally like checking Y20. I'll just check only Y16. This one I'll check only Y16 in terms of the beam. Then we don't have shear wall. In terms of the slab, I'll check only Y12. Then in the rib slab, we don't have rib slab here. Coming to the foundation, I'll check only Y16 as my foundation. Then coming to the ring, I'll also check only Y10 as my ring. Then this one is for shear wall. These things are for shear wall. So I don't have shear wall in this design. So I'll just leave it. I'll not check it. So I'll just click on OK. Then I'll click on apply to all members. I'll click on OK. So I'm through with this. Next thing to do now, I'll come to foundation, click on foundation. I'll still want my compressive strength of concrete to be 25. That's 20. I'll click on OK. Not click on apply to all members, but I have only one member here. Then in terms of sand, I'm having sand, clay, and this, but I've gotten my soil bearing capacity to be 120, and to that 120 in that place what we have is sand. So I'll just leave it. I'll still leave it as sand. Then I'll come over to this grade of steel for foundation. So the yield strength I would like to be using is steel 460, and yeah, I'll still click on update all members. If you click on edit, it still has the setting that we have done before, so I would want you to carry out the reinforcement setting again. So I'll click on OK and still click on OK. Then coming over to this link, I'll choose my strength to be 462. I don't want 500. I'll click on apply to all members, then click on OK. So after this, I'll click on OK. Then after I'm through, after once I'm done with here, then you now come. Assuming I have wind road, I would have applied wind road, but this is a small structure. So assuming I can shake the height, look at the height we're having after story 2, having 6.42. Look at, if you can see it, after story 2 we're having 6.45, so it's not even up to 10 meter. But if it's up to 10 meter, we'll apply wind load. But since it's not up to 10 meter, I will not bother applying wind load. So I'll go straight to my analysis. So I'll click on, we have done building model check before in our previous video. Then now click on building analysis. So in this building analysis, in this building analysis, I'll check this is the design. Some people might just want to first of all run the building analysis, then after they will now come back and then do the design of column and beam. But me, I want to do all of them together because this is just a small building. But if I'm having a very high building, I like to first of all run the analysis, but let me not bother you with that. So I'll just click on column. So once it's after running the analysis, it will design my column for me, it will design my stair for me. So I can click on reset bar. Reset bar is in case where is in the places where I have up to more than, where I've selected more than one type of bar. For example, in column, as me in column, I selected Y16 and Y20. I'll do the reset bar. And also another time, but if you have done your building analysis before, if you have designed it before and I have done interactive design, don't worry, I'll show you what interactive design is. And you have done interactive design and some fails, and you want to rerun you want to redesign it again, don't click on this, because if you click on this, all your efforts, like after you have done your interactive design, all your effort will be in vain because it will scatter all of them. So if you have done interactive design before, after you have designed it and you want to redesign again, don't click on this again. So as me having steel member, I'll click on steel member design check, but I don't have any steel member here, so I'll just click on building design. So we wait for it to carry out the design of our structure. So as if this is carrying out the design of the structure, don't forget you can still get the architectural or plan and practice on your own. It comes together with you can still get the CAD file and practice on your own, because you know practice make perfect. The more you practice, the more you get to learn what I'm explaining here, and the more you get to experience it practically. And two, don't forget the architectural CAD file comes with the architectural plan and also the structural detailing. So in case once you are doing some certain things and you encounter any issue once detailing, you can easily reference back that structural detailing for more clarity. So that's why I also include the structural drawing in the architectural CAD file, so you can get it in the link below. It's in the description and it's also pinned at the comment section. So our beam is designing, and so I think you have done column design, but I not say it column design has been done. So this is the beam reinforcement design. So let's wait for it. It's almost true. So this one here is almost true. So this is it. Yes. If your relative story drift fails, what it means is that you have to increase the size of your column, or you increase the number of your column. That's if you are seeing bad here. That's if it fails in direction 1 and in direction 2. What it means is that you go and increase the number of your column, or you increase the size of your column, one of them. So after seeing this, the next thing to do is that I'll come and click on OK. So we now click on OK. So we click on OK. So we click on close. So look at it. It's now check building analysis. It is marked good. So let's go and view our analytical model. To view our analytical model, we'll come to view. We'll click on view. Then when I click, then we'll now select building analysis model. That's we want to view our analytical model. We'll click on building analysis model. So like let's wait for it to load. For us to see our analytical model. Look at it, building analysis model is showing up. It's showing up everything. Yeah, so this is our building analytical model. Yeah, this is all where it was performing the building analysis. But we can go to this solid model. Let's wait for it. So this solid model is telling us on how it's showing us how the force is being transferred. Yes, it's showing us how the force is being transferred. For example, This one on blue is one carrying the highest load. Look at it. It's carrying a load of 193 kilonewton. Look at it. Why this one's on the edges? Why this column on the edges? They are carrying a lower load. Look at it from yellow downwards and green downwards. Look at it, 94, 98, 78 to even to even 13.1. So the one on edges, they are carrying a lower load. So the reason why these ones at the center are carrying higher load is because we have because they are all surrounded. It is being surrounded by slab all around. Yeah, it is being surrounded by slab all around, so it is carrying load in all direction. Why these ones at the edges, they are just carrying load in just this side. They are carrying load just this side. They are not carrying load this side because there is no slab this side, so they are not carrying a lesser load. Why these ones at the center, they are carrying a larger load. So that means we are seeing that what the software did or what the software design is accurate. So this is what you're having. So let's go back to I can just come here and delete this building analysis model since we have checked it. Let's wait for it to go. It will bring us back to our model. Then we'll now come to design status. Let's go and check our design status to know what we are having. So I'll click on visual interrogation. Then I'll now scroll down to design status. I'll then click on OK. If you can see now, we did a nice job. We did a nice job. We did a nice job. So if you can see now, those on green passed. So if you can see now, most of our, in fact, if I say most or all of them, they are all on green. That means they all passed. And also, if you have anyone on red color, that means it failed. But we are not having anyone on red color. Then if you have anyone on on orange, that means it's expired analysis. Why? If you have anyone on white, it's not designed. For example, look at our slabs. Our slab, they are all on white. The reason is because we have not yet designed our slab. But these are the things we'll do in this video. So right, and if you get your draw, if after design and you're seeing it like this, all of them green, don't just leave it like that and go. Do interactive design. So let's come to our story plan. So okay, we'll turn on the design status again. So click on design status, we click on OK. So let's go to story one. Let's go to story one. We'll double click. So we are now in story one. So remember, even if it passed, even if all of them should pass, do your interactive design. You must carry it out because sometimes the software might over reinforce. So if it's over reinforced, you know how to go about it. So I click on section design. So on section design, let's wait for it to open. Then we will now check. I'm having 2x16, 2x16 is okay, 2x16, 2x16, so it's okay. Everything is okay. So since everything is okay, 2x16, then you can come here, click to see the bending moment diagram. Look at it. These are bending moment diagram. This is that I'm telling you. If assuming this is that I was telling you about hinging. Let me explain. This is that I was telling you about hinging. Assuming you did not hinge, assuming we didn't hinge this our beam now. This thing will not start at 0. It will start at here. That means there will be moments here. It will start like this, then go up. See, we did not hinge here and we're having moments. But since we hinge here, this thing started from 0. But if you did not hinge it, it will start from here. And then in design, ProtaStructure will provide reinforcement to counter this moment. And where if he provides reinforcement to counter this moment, that means it's giving you that means you'll be over designing. That means you are no longer economical in your design. So these are the reason why I say you must hinge your member so that it will start from 0 and it will start from 0. So that means we hinge there and we hinge there. So that's why having starting from 0. But assuming that I will not just hinge one. So people will just see the difference. But assuming it not hinge one now, you see it will start from here and come down. That means there is moment here. That means ProtaStructure will provide for the moment. And also see now, there is moment here and there's moment here. Reason is because we did not hinge these members. We did not hinge here. That's why we're having moment here, and that's accurate. There should be moment here. We should be having hugging moments. And so let's go and check. Let's check. Let me close this now and check back the reinforcement that they provide. You see, we'll be having higher reinforcement here compared to the reinforcement we are having here. So we'll be having not higher reinforcement, higher area of steel required than the area of steel required for this section. So let me just close it. Let me close it. If you can see the area of steel we are having here, 56.67. The area of steel we are having here, because we hinged here. That's why they are giving us more area of steel. But look at the area of steel we are having here, 199 and 178.6. And also look at the area of steel we are having here. Look at the area of steel we are having here. So you see, if you hinge your members, you'll be having smaller area of steel. Look at it, area of steel. You're having smaller area of stairs. So that's the advantage of hinging your member. And also, assuming we're having higher load coming to this now, assuming higher load was coming to this structure, assuming something like this is a commercial building, you see now here will be something like that 3y16, and this like if you not hinge it, will be having that kind of 3y16. So that's why I say hinge your hinge your beams, make sure you hinge it to save cost, to reduce the moment coming on it. Because assuming we not hinge it, here will also be here will be like something like this 119. So that's the advantage of hinging your member. You can say see here that we not hinge that is also 2y16, but don't forget this is a residential building. Assuming now you're working on commercial building, now you see now this thing will be failing. But anyway, don't worry, let's continue. You will still understand. So let's click on OK. So this is how, okay, remember once we clicked here, he brought out this one, and this one, because this is a continuous beam. So once you click here, it will bring out this whole beam. So if we click here, why it will bring out this whole beam. So let's click here, let's do the interactive design of this. I even forgot to mention something. I'll come to section design. So if you are doing the interactive design, don't forget, if your area, if here now, if you know this is the area of stay required, this is the area of stay required, then these ones now are the area of stay provided. This is the area of stay required. This one is the area of stay provided. I am not seeing where utility ratio is here, because I could have explained utility ratio, but don't worry, once we go to the code room, I will explain utility ratio, so for you to understand. So this is the area of stay required. This is the area of stay provided. So make sure that your area of stay provided is not less than 100 millimeter square. Make sure that it's not less than 100 millimeter square. Reason is because, remember, but anyway, it depends on your country. If you are not this United States, the UK, Canada, where you are sure that they don't tamper with standard or they don't tamper with quality, yes, you can go with what the software is giving. But if you are something country like Nigeria or this African country, don't make sure that it's not less than 100, because you know that in Nigeria, Y16 is no longer Y16. Y16 might just be, in all this African country, Y16 might just be Y14 or even Y13. And also the yield strength that you are telling us 460, it might no longer be 460, it might be 420, 430, or even 410. So to counter this lack of to counter that, that's why I say make sure that this your area of stay, this area of stay provided, that's extra area of stay provided, is not less than 100. To counter that, so ensure that in your design. So here you are not having any of them less than 100. Please ensure that to avoid building collapse, because these are some of the things that causes building collapse. It's not that the engineer is not doing a job, it's just that the company that are producing all this reinforcement, they are tampering with quality. They are not giving us the exact quality. So in order for us to prevent the collapse of the building, we do this. Also, another thing that you can do to prevent collapse of building is inside, ensure that you accurately wrap your reinforcement. But we shall do that one more once we come to detailing. Ensure that you accurately wrap your reinforcement, in the sense that lapping length should be 50 times 50. Lapping length is 50D. That's 50 times the diameter of bar. Look at it. These ones are okay. 2x16, 2x16. So I'll click on OK. So wrapping length, let me just be checking and explain what I'm explaining. So wrapping length is 50 times the diameter of bar. So make sure that once at any time, if you are wrapping, that you wrap 50 times the diameter of bar. For example, if you're wrapping, if it's Y12, 50 times 12 is what? 16. Sorry, is 600. That means your wrapping length should be 600 mm. So let's continue. Let's keep on shaking. But due to the length of this video, I don't think I will shake everything. I think I've shaked enough. Maybe if you get the CAD file in the description below, once you are practicing, you cannot check all of them. But due to the length of this video, I will not check all of them. So, but most of them are giving me 2y16. So it's okay. I'll come here, section design, 2y. Okay, see this one. I be seeing this one. This one is giving me 55. So I'll increase this to 3. I'll increase this to 3 because I will not want that what they even give me again. I want it to be above 100 to prevent collapse. So I will increase it to 3. Thank you. So I'll click on OK. So this is how you just do everything. Let me go to story 2. Let me do small in story 2. I'll double click. Then we just do few in story 2 and then continue. Then on your own, make sure you go through everything. So we're having ABC. This is the reason why I told you that I don't normally like applying all these hinges on top of the roof. On our roof section. Look what they're having. Look at what you're having. Area of stay required is 0.09 point. So it's too small. So me, I don't normally apply hinges on my roof road. And also look at the area of stay provided. The area of stay provided is 300 and something. Why in story 1 we're having that area of stay provided is even 200 and something. So the area of stay here is even more. So that's why I told you normally. But you'll be applying your wall road. That's for your parapet road. Just be applying it on your design. So that once you are submitting your brand to whoever, so once the person looks at it, you know that you know what you are doing. So I'll just shake one more because we still have much thing to do in this video. So I'll just shake one more. So I'll click on this one is far above, so I'll just click on OK. So now come over to column. So let me go back to story 1. We'll come over to column. Yeah, we come over to column. So I'll just pick random columns. I'll not shake all everything. So I'll click on this, right click on section design, the same thing on column. So let's wait for it. Let's wait for it. So you are seeing you're having 2 to 5 by 2 to 5, 416. You see, utility ratio, our utility ratio here is 0.2. So now let me explain what utility ratio is all about. Utility ratio is the ratio of reinforcement required to reinforcement supply. That's utility ratio. The ratio, or you can just say reinforcement required divided by reinforcement provided. So for example, as we are having that the reinforcement required is 240 and we provide 200, you see, if you do 240 divided by 200, I'll be having 1.2. That means the utility ratio will be 1.2. And if this utility ratio is more than 1, that means that your column member will fail. If it is more than 1, even in terms of being 1, if your utility ratio is more than 1, it will fail. Reason is because utility ratio is the area of steel required divided by area of steel provided. For example, if it is required that we should if this section requires 240 newton per millimeter square area of steel and I provide 200, if you do 240 divided by 200, I'll be having 1.2, so it will fail. But if the area of steel required is 240 and I provide 250, I'll be having 0 point something, so it will pass. So that means in all of design, ensure that your utility ratio is more than 1. But this one passed, so it's okay. So I'll just pick random color. I'll just pick 5 in numbers. So I've done 1. I'll just pick, okay, let me pick the center ones. I'll just pick 5 in numbers. I'll just pick five numbers. So look at it. Utility ratio 0.1, so it's okay. 0.19 is okay. Let me pick this one. I'll click on section design. So I'm having that utility ratio is 0.4, is okay. It's passing. So I'll just click on random, but on your own you can check all of them. So I'm also having, look at it, utility ratio 0.19. So let me go over to story 2. So look at it. Utility section. So we're having the, you see the utility ratio is 0.14, so it's still okay. It passed. Let's check another one. I'll just check 2 here. Let's check this one. Section design. So we're having, look at it. It passed. Utility ratio 0.2, so it's okay. So we are through with everything now. So what we are going to do now, let's come over to our 3D view. So this is what we're having. This is what we're having. So this is what we're having. See, everything passed, everything passed, everything passed. So the next thing to do now is that we will design our slab. Yes, we will design our slab. So I'll come over to plan view. That's, this one is now under slab design. I'll come over to slab plan view. Then I'll come over to, I'll click on story 1. Then I'll come and click on more there. I'll click on slab strip. I'll click on slab strip. So under S direction, I'm using analytical strip. As we are doing being left and slab design, that's when we'll be using this FE strip, but we are not doing that. So right now, if you can see now, this will pick our boundary. So picking our boundary, this one means, this one now stands for this, like we're having a beam, then in front of it is slab. Look at it, a beam, then in front slab. This one now stands for cantilever, somewhere like this for cantilever. Then this one now stands for a continuous beam. That's, for example, inside here, as we want to do is slab C from here to here. But don't worry, as we are doing it, you understand. So at start, I want to first of all do here. At start, I'm having cantilever, so I'll click on this. And at the end, I'm also having cantilever. I'll click on this. Do you understand? Then I'll now do I'll just come close to it. Hold my control key to strengthen the line, and then click like this. Yeah, it has designed. So if you look at it, I'm having T12 at 250 spacing, so it's okay. Then I'll come, okay, look at this one. Let me do this one. I'll not do everything, so I'll look at this one. I'll do this one. So this one, I start. Look at it. I start. I'm having this, which is this, a beam, then slab, which is this. Then at the end, I'm having slab and beam. So look at it, slab and beam. So I'll click on this. Then I'll now zoom. Blue, right? Remember, this is for S direction. Then place it here. So this is what we're having. So in this case now, okay, look at it now. In this, let's do now for this case now. This one now, for this is now Y direction. I said I will not do everything to save time. So this is now Y direction. This is Y direction. So if you look at this one, I'm having cantilever and slab. So I'll click on this. This cantilever and slab. I'll click on this. Why here? I'm having slab. I'm having slab and beam. So look at it, slab and beam ending. So I'll click on this. I'll go from here to hold my control key to here. It has designed this in y direction. Then let me just say, as me, I want to design only for this, only for this. Okay, let me do the whole of this. So for here is cantilever. I'll click on cantilever, and here is slab. So I'll click on this boundary one. So I'll pick here and hold my control key to here. So this is what I'm having. But after, you can now continue all of, okay, look at this one. As me something like I want to design only inside here. So I'll come here and pick. Look, I'm having beam. I'll come here and pick beam. And also I'm having beam. I'll come here and pick beam. So I'll design only for this. Hold my control key. So this is it. But I've not really designed everything. Let me Control Z to undo. In your own, you do it accurately. But me, looking at, if you look at everything here, I'm having two eyes, T12, that's Y12 at 250 spacing, Y12 at 250 spacing, Y12 at 250 spacing, Y12 at 250 spacing. So me, in my own detailing, what I used to use is Y12 at 200 spacing. Reason is still what I told you concerning beam. I'll use Y12 at 200 spacing because most of the African countries, even the one even where I'm located country, which is Nigeria, most of our company, they tamper with quality. Yes, the steel strength, that's the yield strength of this Y12. The yield strength we assume to be 460, might be 410. Even the Y12 again might no longer be Y12, it might be Y10. So that's why in my design, to counter all these things, I'll now do Y12 at 200 spacing, even though that design gave me 250 spacing. For me, in all my slab, I'm using Y12 at 200. In all my slab, at least the space will be at least 200. So we have done this slab design, and we have done interactive design. Right now, we have come to the end of this tutorial. In our next video, we'll be doing our foundation design. Then after foundation design, we'll now export after our foundation design, we'll now extract our structural drawing in Prota detail. Then we'll now export it to AutoCAD. Then we'll now carry out our structural detailing. All these things will be done during the course of this video. So you get to learn everything. So right now we are through. Watch out for our next video.